Okay, so our augmented matrix here is in the span if and only if we have a solution. The augmented matrix looks like this. N is bigger than M, so you have more columns than rows, meaning that you're going to get rows that have all zeros except maybe for the number over here, right? Okay? Now, if you have a row like this and the number over here isn't zero, then you don't have a solution, and that vector x1 through xn, whatever it was, isn't in the span. Okay? But there are vectors in the span. Like, for example, each one of these vectors is in the span. So if you put the coordinates of any one of these vectors in here, then you've got it, okay? And I might well ask you to explain that, okay? Very much related to the problem that occurred in most tests. Okay. So, n's greater than m, so you will get rows of this form, but this thing won't necessarily be zero. Okay? That depends on what your x1 through xn is. Okay? So, actually, if you just randomly select an x1 through xn, your chances of hitting one that's in the span are pretty much zero. Okay? Or minuscule, depending on what set you're choosing your numbers. So if you're choosing from real numbers randomly, you're not going to ever hit one. Okay? And we'll talk a little bit about that. But there are vectors that will give you this. Okay? You could even start from, you know,
it's actually the tail cone. So what you want to get on
I'm not sure even want to say it, but you could start from a matrix that has this form with some zeros. You have rows of zeros over here, and build back up into this matrix and find vectors in the span. There are easier ways. Okay? It just okay. So we are going to get rows like this. Okay? In a random selection, it'd be unusual to find vectors. Really unusual to find vectors that don't give you this form or this isn't zero. But they exist. Every one of these vectors, every one of these columns would work. So I'll say the star won't necessarily be zero for a given vector, okay? Although if this is one of the original vectors or a combination of one of the original vectors, it will be. Okay? But for some it will. Okay, so I say, if so, that is if so being this be zero, okay, then the vector's in the span. Make sense? You want to understand that at the level of simultaneous equations, at the level of reduced matrices, okay? Everything you know about these things, then you have a good picture of what this is saying, okay? Okay.